Alright, so let's talk about question number 5. The number of squirrels in the forest is being studied. The number of squirrels and in the forest 3 years after the start of the studies modeled by the equation is available. Okay, so find the number of squirrels in the forest at the start of the study. So as you can see, I already told you, okay, if you read the question carefully, then you will be able to do this question easily, scenario based ideas. So beta T years actually will count after the start of the study. So obviously at the start of the bill, exactly at the start of the study, so T years will be beta 0. T years obviously will be 0 at the start of the study. After that, T years will count actually. T1, 2, 3, 4. So what I want to find the number of squirrels, and number of squirrels is actually represented by n, as you can see. It is represented by n. So I want to find n value. So put t equal to 0 and get the answer. So the answer will become, stay attentive, anything raised to the power 0. Answer is 1. Hello, keep your eyes on the screen. 4000 divided by 19 plus anything raised to the power 0, 1. 400 divided by 20, cancel. Answer will become 20. So n value is 20. That is a very easy, straightforward. Let's move forward. Take derivative dn over dt. Okay. How to take the derivative of this fractional function? Everyone knows. Straightforward. Do not worry about that. Do not try to overthink about this question. Apply quotient rule directly. How to apply quotient rule? That is u and that is v. Everyone knows. Put the line and take the square of denominator, which is v, and leave v as it is, and take the derivative of u separately. Alright, so the derivative of u will be 4000 multiply 0.1 multiply a raised to power 0.1t minus u as it is. Take the derivative of v, and v is 19 plus e raised to power 0.2. The derivative of v, the constant derivative has 0, and the exponential will be, first I will write as it is and then 0.2. Perfect. So let's simplify further if it is possible. 4000 times 0.1 times 19, so 7600 e raised to power 0. But just multiply this one inside the bracket, and plus 400. So when e raised to power 0.1 multiply with this one, so bases are same, powers will add, so it will become 0.3 t minus 800 e raised to power 0.3 t. Alright, perfect. Let's move forward. The number of squirrels in the forest is at the maximum. Yes, but this question is also related with derivative. Number of squirrels is at the maximum. Maximum, minimum, stationary point, critical points. As you know that I have to put dn over dt equal to 0. So put dn over dt equal to 0 and show that exponential equal to a constant. The right side as it is. Yes, which denominator will remove or not? Yes, because it will shift into another side. So what will be the remaining term? Only numerator. Okay, equal to 0. Now these two terms are as it is. It can be subtract. So beta t is actually available and t is capital T. So put capital T in place of small t and minus 400 e raised to power 0.3 t. So 400 e raised to power 0.3 t equal to 7600. So let's divide exponential with each other and constant with each other. It's going to be equal to, bases are same, then you will subtract the power, so you will get e raised to power 0.2 t equal to 19. That is what we want to show. The a value is actually 19. A is actually 19. Perfect. Perfect. Hence find the maximum number of squirrels in the forest. Find the maximum number of squirrels in the forest. I want to find n value. So where is the function actually? That is the function of n. But before that, I need to find the value of t. Okay, so let's figure out the value of t. Everyone knows how to find the value of t. Take ln on, because the base is a. Shift 0.2 t. So t will become, and just substitute over here n equal to 4000 e raised to power 0.1 t value divided by 19 plus e raised to power 0. T value, and then you will get the answer. The answer should be nearest to whole number, as you can check from calculator. No.